LC oscillations. The following circuit, where inductor and capacitor are connected in parallel, is a tank circuit. Initially, the capacitor is charged to a maximum of Qmax or Qm from a DC source, so that, say, the top plate is positively charged and the bottom plate is negatively charged, as shown in figure A. Now we can take up the study of LC oscillations, that is, the oscillations between an inductor and a capacitor connected one parallel to another as a tank circuit. Initially, the capacitor is charged to a maximum charge of Qmax from any DC source, so that the top plate is positively charged and bottom plate is negatively charged, as shown. At this instant, the inductor is connected across the capacitor, as shown, so that the things to follow will be as I am explaining to you. At t equal to 0, the capacitor starts to discharge itself, and this flows as current through the inductor, as shown here. As you can see, the current through the inductor is from top to bottom. That's why A is marked as plus and B is marked as minus, from top to bottom. This current increases from 0 to I max during the interval between t equal to 0 and t equal to capital T by 4. At the same time, the charge on the capacitor reduces from Q max to 0. The following figures A, B, C, D, E will show the status of the tank circuit at various times. As explained before, at start, the energy on the capacitor is Qm square by 2C, because Q is Qm. And since no current flows through the inductor at start, half Li square becomes 0 at t equal to 0. So Ub equal to 0. And Ue is Qm square by 2C. Comparing this with a mechanical spring in harmonic oscillation, U, the potential energy of the spring, is half Ka square, where K is spring constant and A is amplitude of vibration. And kinetic energy, because it is at the extreme position, the kinetic energy is 0. This is corresponding to stage 1 of the tank circuit. B represents the status of the tank circuit at any time t between 0 and t by 4. As you can see, the capacitor has partially drained out, because there were 4 pluses there is only 2 pluses here in the second figure. So part of the charge has flown, and hence there is a partial current through I, which is I less than I naught but greater than 0. In the previous figure, I was 0, now the current is some I between 0 and I naught. Therefore, U is the potential energy, the electrical energy at the capacitor. Because of some charge that is remaining there, U is not equal to 0, but it definitely U is less than U max the capacitor. K, that is the kinetic energy, the magnetic energy at the inductor, is also not equal to 0, but it is less than the K max that will be at the next stage. Now coming to stage C, let us see the status of the LC circuit. As you can see from the figure, no charge remains at C, but all the charges have driven current through this. The current through the inductor is maximum, that is Im, and the charge at the capacitor is 0. Therefore, UE becomes 0 and UB becomes half Li max square. So energy is all magnetic at the inductor and energy is nil electrical at the capacitor and all magnetic at the inductor. Comparing this with the oscillations of a spring, it is similar to a case where the mass is at the mean position. For this, U is 0, potential energy is 0, and kinetic energy is maximum, which is half mv max square, as you can see here. The time period the time for the status from A to change to C is T by 4. And the time for the status to change from A to B is some T less than T by 4 greater than 0. Coming to E, figure E, let us see the status. Here, once the current in the inductor has reached a maximum, the current will start decaying from I maximum to 0. However, this current will charge the capacitor. Now the lower plate is positively charged and the upper plate is negatively charged, and hence there is some charge Q that is stored in the capacitor, and there is some current that is being drained out of L. So your current, the electrical energy at the capacitor is not equal to 0, and the magnetic energy at the inductor is also not equal to 0, but it is less than UK max, and here U at the capacitor is greater than 0, still it is less than U max. Comparing it with the spring, it is as if the mass has gone to the other side of the mean position, but not to the amplitude position. Therefore, U is not equal to 0 and K is not equal to 0. This is the time for this stage is between T by 4 and T by 2, the intermediate stage, some T. For the next stage F, that is after T by 2 from start, the capacitor gets fully charged with the whole of the lower plate being positive and the whole of the upper plate being negative, and the total charge on the capacitor is Q max, and the current at the inductor, as you can see, there are no lines here, and therefore there is no current. I at inductor is 0. That way speaking, the energy at the capacitor is maximum, and that is equal to Qm square by 2C, and the energy at the inductor is 0. Analogously, it is as if the mass is at the maximum negative displacement in a spring, and U is equal to half Ka square and K is equal to 0.